Alright, welcome to the fifth video in this series. We're going to go over the derivative of sine and cosine. In this video, we're not going to prove it though, because it's just a bunch of trig identities, and then if you care about proofs, then you're just gonna go down a rabbit hole of, well, prove the trig identities, and honestly, I don't know how to do that. So what we're going to go over is the derivatives of sine and cosine. Then we're going to do some examples which will involve the chain rule, which is in the last video. So a little bit of review there. But real quick, I want to go over another derivative rule. I don't know what it's called, but let's make this pen a little thicker. So if we have dy dx of x squared plus 3x, this also equals d dx of x squared plus d dx of 3x. Kind of just the distributive rule. This is like a function, so we can just distribute it inside the parentheses and just take the derivatives separately, then add them together. So we get 2x plus 3. So real quick, let's do an example, then we'll get into our lesson. So let's say we want to take the derivative of 3x to the fourth plus 3x to the cubed plus 12x squared plus x plus 2. Very long derivative, but what, if you remember, is we can just distribute this to everything inside. So let's undo that. So first, what's the derivative of this? Plus that, plus that, plus that, plus that. So, well, we're just going to do our power rule. So it'll be multiply out in front, subtract by 1. So we'll get 4 times 3 times x to 4 minus 1 plus multiply out in front minus 1. 3 times x to the 3 minus 1 plus 2 times 12 times x to the 2 minus 1 plus this is x to the 1. Let me bring out the 1 and subtract. So we get 1 times x to the 0 plus, and then right here, 2 is just times x to the 0. We multiply the 0 out in front and we'll just get 0. And then if we do some simplifying, we get 4 times 3, that's ugly, 12 times x to the cubed plus 9 times x to the squared plus 24 times x plus 1 plus 0. And that would be our answer. So it's just one example, but in that example we had 5 different subsections, so I think it made it pretty clear. Let me just check my work, make sure it's correct before we move on, because I was going a little fast. Yep. So now let's go into our main lesson of today, which is just derivative of sine of x and the derivative of cosine of x. Now, I'm not going to prove these two because, well, if you wanted to prove them, you would do the limit as delta x approaches 0, our basic f of x plus delta x minus f of x all over delta x, and you would just plug in f of x, sine of x plus delta x here, minus sine of x all over delta x, and then you would use trig identities to simplify that, but I'm always just rusty on my trig identities. I didn't really pay attention to that in pre-calc, so I'm sure like Khan Academy has a good video though, which again, like, why are you here? Just watch Khan Academy. But anyways, so what we're just going to memorize for now is sine of x. The derivative of sine of x equals cosine of x, and the derivative of cosine of x equals negative sine of x. So, what we can do with this is we can also say that if we have the derivative of negative sine of x, then it'll just be equal to negative cosine of x. And if we have the derivative of negative cosine of x, then it'll just equal to sine of x. So that's pretty much what we memorize, but let's go into some examples. And this is where our chain rule proof will come into. And hopefully the review of chain rule while going over sine and cosine functions will make it more clear. Also, I did make a mistake in the last video, so please check the comment and description. It was at the very end. I forgot to carry a constant. It was just a stupid mistake. But let's find the derivative of sine of 3x. So inside we have a function with respect to x, and that's 3x. So we're actually going to need to do some chain rule. So first, with chain rule, we just take the derivative as normal, where this is actually just, if we want, we can just write this as you just ignore the inside. So it would be cosine of 3x. We ignore the inside. But then, of course, we also have our chain rule, so we'd have to multiply by the derivative. And the derivative of 3x with respect to x by the power rule is just 3. So we multiply it by 3, and we get 3 cosine of 3x. And that would be our answer. Now let's make this a little more neat. But there's a faster way to delete all this. Don't forget to like and subscribe. Alright, let's do the derivative of cosine of 4x cubed. So again, we memorize that it's just negative sine of x, and our x in this case would just be 4x cubed. I don't know, it's kind of confusing because like this x right here it's just a variable that you plug in, and in this case we actually plugged in a complicated variable instead of just like a simple variable of x. We have this variable x. We can even say like a different variable like y, and y equals 4x cubed. So just pretend that this is 4x cubed. So we move on to, we have cosine, and we know that's negative sine of 4x cubed. And then we also need to do chain rule, where we multiply the inside. So let's do that. We have our 4x cubed, and we're going to multiply out in front and subtract 1 power. So we get 3 times 4 times x to the 3 minus 1 equals 12x squared. So we need to multiply this by 12x squared. So the derivative of cosine of 4x cubed is going to equal negative 12x squared times sine of 4x cubed. And that's kind of a ugly answer. We still have like x squared, x cubed, sine function still in there, but you're going to get really used to these complicated answers to like simple problems. And that's actually like pretty much as simplified as you can get it, so that's our final answer. Let's move on real quick. Say we have a radical function, like, I don't know, 1 plus 3x. Well, just some algebra right here. If we want to take the derivative of it, well, we know the power rule, which is just x to the n equals nx n minus 1. So let's rewrite this in a form that we can do that with. And, well, actually, if you remember from pre-calc, the square root is actually just the 1/2 power. So let's say 1/2 is our n. So let's do that real quick and rewrite that down here. We're running out of time, so I'm going to go a little fast. And we're going to bring out the 1/2 in front and subtract 1. So we get 1/2, and again, we still have the chain rule here. If this was just x, then we'd have 1/2, and then we'd bring out the 1/2 in front, and we have x to the negative 1/2. But, I mean, we're going to do that same process with the extra step at the end, where we'd multiply by the derivative. So let's get rid of that, and I feel like I jump around too much, I might confuse you guys, but so 1/2 minus 1, which is just negative 1/2. And then we also have the chain rule, this inside function, where now we need to multiply by the derivative of 1 plus 3x, and this is just, well, the derivative of 1 is just 0, and the derivative of 3x is just 3, so we get 3. So we get 3 times 1/2 times 1 plus 3x to the negative 1/2. And negative 1/2 is just a square root in the denominator, so let's finally rewrite this as that. So that's our final answer.